Now, in this video, we're going to do a homework help for section 10.3, and these are some of the examples from practice and certify to give you a little bit of tutorial direction. So for the first item, revenue function is defined by this that I've written out big here, where X is the number of units sold, and that would be 8 here. And then the price is represented by this, and there's an X in there as well, that is an 8. So in winding this up, we're going to say 8 here, and then the price is 44, and then we'll put the 3 in parentheses. And then it's a negative X, so it's going to be caret negative 8 divided by 4. Put that in your calculator and see what you get. And I get 39.111, keeps repeating. And we're rounding off to 2 places, so it ends up $39.11. In question 2, it's just a matter of putting this accurately into your calculator. They're giving us the value of the function, which is the unknown. In this case, it's t. So we put in there 20.7, Euler's E, then we put a caret, dot, and again, some places the caret's already built in, 2.24, and then times your t value, 11.5, and then enter, and I get 327.0567. So again, our third decimal place, the thousands, is a 6. So we're going to drop the 6 and add 1 to the 5 to make that a 6. And that's the answer. Now, for these graphs, when we're asked to match up with a function, so this is the function, let's say, of a, is this a whole number or a fraction? Well, it looks like a fraction, but actually this is 2.75 actually. Because if this were 12, this would be a 3. So this is like a big number. It's not less than 1. It's greater than 1. So we said anytime a function is greater than 1, the shape of the graph is going to look like that. Now, when you put a 0 there, this to the 0 power is 1. So this is going to go through 1 here. So now let's do some matching. Is this going through 1? Yes. But this is when it's a fraction, like 1/5 to the x power. Whole numbers, we said numbers larger than 1 have this shape. So is this going through 1? It has that sort of shape. No, this is going through a negative 1. And as we go down here a little bit, and if we can stay down, there we go. This is not going through 1. But this one is. So just from the hip, knowing basic shapes of what our functions will look like. We can pick out this one, and this one was done correctly here. Now in this next one, we're asked to find the future amount, which is A. This will be our principal, our rate, the time, and it's compounded continuously. So we have to supply the continuous rate formula, which is principal times the letter E, RT. So now it's just a matter of filling it in. 3255 as our principal. Oh, I got that wrong by one number, so you have to correct that. Be sure you're copying things down correctly. So check your work. I finished putting in. Now on my calculator, I have to put in the caret sign. But on some, once you hit E, the caret sign is there. So be careful. You have to know how to use your calculator properly. Now you have to convert 9% to its decimal form, 0.09, and then 5 years. Put that into your calculator, and you get then $5,057.81, where you've rounded off to 2 decimal places. Now in looking at this next one, again, we're just to match up the graph. Now is this a fraction less than 1? Or in an improper fraction greater than 1? Well, this is greater than 1. If that were 8 over 4, that would be 2 to the x power. But remember, anything to the 0 power is 1. So we're looking for something that's greater than 1. That's going to basically have this shape. And then we start matching up. Well, here, this has the shape, but it's going through a -2. This has the shape, and it's going through a 1. So this happens to be the answer. And then just scroll up a little bit to see the other choices. This one's not going through 1. And this is, if it were a fraction, less than 1, would have this shape. This is the answer. Let's go on. Now, in eyeballing this, we're wondering which one would it match up with? Well, again, because this is a whole number here, it's larger than 0, we know that this general shape of this is going to be something like this. Now, so we can eliminate this one. This is not going to work. This one's not going to work. So it's just a matter then of checking between this one, where it's sort of in that shape, and this one. And again, shooting from the hip, you see you have a -3 there. You might think that it's going to shift it this way, or it's going just to shift it down a little bit more. Well, for something like this, it's going to shift it down, as you can see that looking at the answer, this is the answer here. So again, that one was rather challenging. And if I were a student, I would go to open the tutor and then review what is mentioned here. I don't want to make this too long, but you would then continue on to the next pages here, and it would go through the protocol where again you would reject these because these are fractions, and it goes through in some detail why you wouldn't pick this one, and where in fact this next one is the answer. Now for question 7, again, this is a matter of substituting into your formula. And the t value here is 5 minutes. So I would put that into a parenthesis after you put in your Euler's E. Check that out, see what you get. And what you'd have to do is practice putting this into your calculator so you end up with the correct answer. I had this plus a few more places. We're rounding to 3, so we're dropping the 2,4 and leaving it like so here, which is what this person had. Okay, let's go on. And here, once again, is something we've done before. We have to put these values in there. Let's see what you get when you do it. So there's the formula. Our cost is 618, parenthesis, 1 minus 0.11, close parenthesis, caret, 4 for the time. Hit enter and you get this. And you need to round to 2 decimal places. So you go to the third, that's a 7. So you're going to drop it and then add the 1 to the 4. If it was less than 5, you would just drop it. If it's greater than 5, you drop it, add 1 to the second digit there. Okay, so this becomes a 75. Now, when you look at this next one, notice it's a negative exponent. So what we might do right away is change that to a positive x. So right now this is a 4.5 to the negative x. If I were to make that into a decimal fraction. But once I make this a positive x, it flips the 9 halves and it becomes 2/9. So this is a fraction. What do fractional function in a graphic form look like? Fractions. Well, they're going to have this pattern, where if this is 0, it's going to go through 1. So this is not going through 1. And I could look at all the others. This one is going through 1 and has that shape. This happens to be the answer. And if we just look at some of the others here, this is not going through 1, and this one's not going through 1. So again, it's a matter of matching up. You don't have to make a big t-chart. You might just make that one of if x is 0. But the key to this one is to make this positive, and then flipping that, and then it becomes a fraction, a true fraction. Okay. All right, the same explanation we had for the previous one now works here. This is a fraction. It's going to have generally this shape. It's going to go through 1, and this is the answer. These are just other things that, again, if you understand the basic principle, then it's easily solved. Now, for something like this is a little different. Now, looking at what we see here, this is a whole number, again, greater than 1, so it's going to have this basic shape. So we have this one, and this one to choose from. That's our basic shape. Now, if x is a 0, this is going to be 1, and it's going to go through. This becomes a, and I'm making a little t-chart here, you can see it a little bit better. So if x is a 0, then this is a 0 here. So anything to the 0 power is 1. So this part now becomes 1. And we go 3 times 1 is 3. So this curve is going to go through at 3. So this person had it incorrect. They had it going through at 5, but it goes through at 3. This is the correct solution. So the student had it wrong, and again, you can explain the error by going through the tutorial here, but I did it for you. And we're almost finished. This one's a little bit tricky, but again, let's use what we know. This is a whole number, or a number larger than 1. It's not just a less than 1. So we know our general shape is going to be this. Now, what value of x would make this exponent 0? Well, a -3. If x were a -3, then this would be -3 plus 3 is 0. Anything to the 0 power is 1. So we're going to look on our graph for a -3, a 1. So we'll look here, -3, nothing's there. In fact, this is a fraction. All right, -3, 1, 2, 3, 1. No, that's not it. So let's go look at the others. Keep that up there. And we might just as well go to the answer, because there it is. -3, 1 is right there. And that's the answer. And here, -3, 1, 2, 3. No, see, this one's off a little bit. So the only one that would fit that, when x is 0, that is a 1, is this one here. Okay, using a little strategy. Our last one. Okay, looking at this one now, we have 4 to the -x. Well, we said this, if it were a positive x, would be 1/4 to the x. All right. So we've determined then that this is going to be a fraction, and it will look in its general form like so. So this would be a possibility, this would be a possibility, this would not, and this one would not. Now notice we then see we've added here a 4. So this is a positive 4. So if we go up 4 right here, there's our positive 4. There's our shape of our fraction. And then it's going through in a sense with our new asymptote here, a 5. Okay, this was rather long, and I don't want to keep it too long. I made it long enough already, so we'll wind it up.